It's been 10 years since we lost a commercial aircraft carrying 239 people, Malaysia Airlines Flight 370. And even today, with all our 21st century technologies, no one knows where the airplane is. I think it's sobering. How can something so large vanish without a trace? But while this is a serious issue, I might have something to say, or perhaps a question to ask. On March 8, 2014, Malaysia Airlines Flight MH370 departed from Kuala Lumpur, bound for Beijing. Not long after takeoff, it lost contact with air traffic control while flying over the South China Sea. Despite attempts to locate the plane, radar data showed it deviated from its planned route, heading southwest across the Malaysian peninsula and into the Indian Ocean. After initial confusion, international search efforts kicked off, focusing first on the South China Sea, then shifting to the vast southern Indian Ocean based on satellite handshake pings received from the aircraft. Months and years passed, with no conclusive wreckage found, except for a few pieces believed to be from MH370 that washed ashore on distant islands like Reunion. We all know the other details, but the issue is, where did it go? Besides the countless theories of what might have happened, the fact remains, we need to see the plane. If it hasn't been abducted by aliens, it's here on Earth. And while we've focused our search efforts in specific areas over the years, I can't help but wonder, what if we combined different technologies and searched everywhere? Before you're taken aback, hear me out. Technologies build upon one another, and for any success, industries borrow and lend information. It's been 10 years of concentrated effort, but now we have AI on our side. As a layman, I might not understand all the complexities, but here's the thing. We're looking for an aluminum wreckage under the sea. There are technologies from various fields that, while not made specifically to find planes, can detect unusually large pieces of certain materials in unexpected places. Consider technologies like sonar, AI-enhanced data analytics, satellites, and remote sensing. Each of these systems plays a role in detecting objects across vast distances. Oceanographic mapping technologies already survey the sea floor, sometimes stumbling across anomalies they aren't even looking for. Imagine the potential if industries openly shared such discoveries. A shipwreck reported in one industry might provide a clue in another. Sonar scans the seabed with acoustic signals, and satellite-based systems can detect subtle environmental changes on the ocean's surface. AI can sift through massive datasets from multiple industries to identify abnormal readings. If we can detect elements light years away in space, surely there's a way to detect an aircraft's materials right here on Earth. What if we tried using technologies from different industries to help find MH370? We may not know the intricate technical details, but here are a few tools that seem promising, and perhaps experts could consider incorporating them into the search. Sonar, sound navigation and ranging. This technology sends sound waves into the water, and by listening to how those waves bounce back, it can reveal what lies beneath. Sonar has been used to map the ocean floor and find shipwrecks with incredible detail, almost like painting an underwater picture. Could it help us pinpoint airplane debris more accurately? LiDAR, light detection and ranging. LiDAR shoots laser pulses to measure distances, often from planes or drones. While it works better in shallow water, it can uncover features that sonar might miss, like unusual objects on the seabed. If experts used both sonar and LiDAR together, it might give a more complete view of the ocean floor. Machine learning with bathymetric data. Advanced AI systems, like models used to analyze seafloor images, have already shown success in identifying shipwrecks. One example is the YOLOV-3 model, which was trained to tell apart wrecks from other underwater features, achieving impressive results. Perhaps AI could comb through sonar and LiDAR data faster and smarter, flagging areas that look promising for further inspection. These tools are already making waves in fields like archaeology and ecology. Why not use them to search for MH370? If different industries share their discoveries, especially when something unusual is detected in the ocean, it could lead us in the right direction. After all, if we can detect distant objects in space, surely we can find a plane here on Earth. As an example, Air France 447 was found through a combination of tools and techniques from different industries, and it took nearly 2 years of search efforts. Experts first used ocean drift models to estimate where floating debris could have traveled. Once the search area was narrowed down, sonar systems were deployed to scan the deep seabed. What made a difference was underwater drones, AUVs, which could explore areas beyond the reach of human divers. But speaking of Flight 447, there's a lingering question I can't shake off. The Airbus A330, like the one in Air France 447, had anti-stall technology. We've heard of it in incidents like Qantas 72, where it malfunctioned. But, with everything the pilots were doing that night on Flight 447, why didn't this system kick in to prevent the stall? Isn't this the exact kind of situation where it should have worked flawlessly? We mostly hear about these systems when they fail, but to me, 447 seems like the perfect scenario for it to prove its value. When I think about it, I feel like there is a void there. What happened? The search for MH370 does not have to wait for a new official campaign. Instead, we can tap into ongoing projects across industries and use technologies that are already gathering valuable data. Ocean mapping efforts, ecological studies, seismic surveys, and satellite monitoring generate massive data sets that, if processed correctly, could offer insights into new search areas. By sharing data across sectors, integrating machine learning tools, and analyzing anomalies, such as unexpected material on the seabed, we might detect the wreckage as a byproduct of other research activities. The example of Air France 447's recovery teaches us that breakthroughs come from collaboration and persistence. When sonar data, underwater drones, and satellite tracking were combined, the seemingly impossible became achievable. The lessons from that search also raise a technical question about MH370. But here's another thought. What if the plane crash-landed somewhere on land? With the vast uninhabited areas on Earth, this scenario can't be entirely ruled out. It adds yet another layer of complexity, emphasizing that the answer could lie outside the expected search zones. Sharing this video with experts and professionals could spark new ideas and analyses, turning an unlikely discovery into a real possibility. Every insight counts, so let's keep asking questions and keep the search alive.